Quick podcast. Okay. Okay. We rolling?
Go.
Okay. Hello, and welcome to the CADimensions 3D Printing Podcast. My name's Adam, and then we have
Kevin.
And Ken.
And behind the camera, we have Ben.
Hi.
So at CADimensions, what we want to do is give engineers everywhere the best tools possible that impact them that empower them to impact the world. Getting my words mixed up there. It's a Monday. We don't usually shoot these on Mondays, so.
But someone decided to go to Disney World or Disneyland and ruin the whole schedule.
Sorry, I threw everything off schedule.
Yeah. So if this isn't as entertaining, we apologize.
Let's blame it on Monday.
Anyway,
Monday.
yeah, it's the Mondays.
You can't have that disclaimer at the beginning. Everyone's going to turn it off.
Well, I'm taking my chances.
We're going to give it our all.
We think this podcast is one small way that we can help empower engineers with technology and stuff like that. And now it's pretty exciting because we're on Spotify and iTunes and
No,
Google
not iTunes yet.
Podcast. Not iTunes yet, but maybe someday.
SoundCloud.
SoundCloud. Google Play Radio. That was the nice one. Stitcher, which is easy.
Yeah.
Obviously YouTube.
So we're everywhere, basically. You can get us just about anywhere.
We're all of the good places.
I don't know if we have enough episodes to be on iTunes yet. They said try back a few more episodes.
Try back when you're cooler.
Try back when you're better.
So stay tuned for next month's show, which is going to be amazing.
Maybe it'll be on iTunes someday. But regardless, now instead of just watching it on YouTube, you can listen to it anywhere.
Napster.
Yes, Napster especially. So let's dig right into the 3D printing goodness then, shall we?
Yeah.
Our first story, we had a lot of great feedback last month on the 3D printed concrete houses. So I wanted to kind of follow up with that with a story from this month where a company in the Netherlands made a concrete 3D printed bridge.
I saw that, yeah. It was unique because it was a very industrial application. Mm-hmm. If I recall the image correctly, it was like a bridge between two building platforms, basically. Mm-hmm. So it was a man bridge. It wasn't very big. It was not meant to cart a lot of stuff, but it was kind of a neat application for it, I think.
Yeah. I think it's more interesting with a bridge because bridges have, I think, more engineering that go into them than just like a building. A building doesn't have to move or flex or have any load on it other than weather. So it's a little bit different, but it's still concrete printing.
But it also makes you think about how, the future warehouses and manufacturing facilities are going to be laid out when you have, if a piece of your concrete bridge gets, damaged, you can print a replacement. You can easily fill in a gap. You don't have to necessarily shut down production for a month because you can't cart material from point A to point B. You can just, hang on, let's fill in that space. So it could change things in ways we don't really know yet.
Yeah, I think the construction industry as a whole, and this is something they talked about, was as a whole, the construction industry hasn't changed much for decades. I'm sure better, faster, cheaper, like incremental improvements in everything, but nothing like revolutionary. Ken, what's your take on this 3D printed bridge?
Well, the two things I found most interesting had to do with they talked a little bit about the topology optimization, where they talk about, with the bridge, they tried to use the least possible amount of material to achieve the weight requirement or the structural capacity. And then the other part, forgetting what the second part was.
Because the way that the bridge was laid out, it wasn't like you would imagine, a truss bridge. It was
It's a very organic shape.
Yeah, it looked like how we've seen other parts before that use that topology optimization to show how, it might have some funky angles and odd shapes to it, but that's really, the ideal position.
But I believe, if I remember correctly, the article said they use 60% less material.
Yeah, that's right.
Than the traditional way they'd make the bridge out of concrete.
So what I don't understand, though, so if you have this free structure between two places like that, I can see a house where you're starting from the ground and you build a base. Is it just floating?
You don't print the bridge in the air.
Okay. Well,
You print the bridge on ground, and then you install the bridge.
Yeah.
Makes a lot more sense.
It's
now.
not.
Yeah, there you go.
Makes a lot more
It's
sense
not.
now.
Glad
That would
we
be
switched.
really cool.
That's kind of
But-
what I'm thinking. Is like a
no.
little 3D printed bridge robot, just kind of.
I've seen that happen where they have like two robotic arms with like kind of tank treads.
Yeah.
And then they weld a bridge and then like go on the parts that they actually welded.
Did
So
they
it's
do
like-
that in Asia?
Somewhere
China?
in Europe.
It took like
I
2
think-
months to build
Yeah.
the whole bridge.
It
Yeah.
was a stainless steel bridge, though.
Yeah. A beautiful stainless steel bridge.
How long
But
did this one take?
they didn't say in the article, which is odd because usually
It didn't
in
look-
houses they always stress like, oh, built in
Time.
24 hours or
Yeah,
something
it didn't
like that.
look like it could have been with 8-10 meters or something like that.
Yeah.
maybe, but so who knows? But I think it's definitely interesting when you, in terms of like our structural environment, as we start to see more things that use that topology optimization,
Mm-hmm.
it's just going to be weird for us to go about our day and see like goofy looking things that
We're-
don't look like they rightly belong. But
Yeah, we're really just waiting on simulation to catch up.
yeah.
Because the reason we can't qualify a lot of these new designs is because we can't verify them through simulation.
Mm.
At least not.
I think
not,
we're getting there though.
Well, so-
not
look at-
additively, which is really. I mean, there's not. It's very hard to make a lot of these shapes unless you're using an additive method. And since
Right.
we can't simulate additive methods, well, it's very. There's tons of people working on it right now, but because that's not nailed down, that's why you probably won't see a lot of major changes
I could even
yet.
see like a bridge over a canal. You know
Yes.
what I mean? Like a bridge that you would drive over or something like that, and you would have, just odd, funky shapes. It wouldn't
Yeah.
look, really traditional. So we talked last month about, 3D printing houses, and I think
Right.
a bone of contention that a lot of people had questions about was how do you put rebar infrastructure
Mm-hmm.
into a home like that? And I think that when you talk about a bridge, you have to talk about structural integrity and not just a slab of concrete.
Right.
So I wonder how they're managing that.
Yeah, I'm curious too. I know they mentioned like a proprietary concrete mix of some kind,
Sure.
which pretty much all of these concrete 3D printing companies mention.
Right.
And they also talked about embedding sensors in the bridge
Yeah.
to help monitor it and like predict the life of the bridge and how it's
Oh.
performing. So bridges, they have to have some flexure to them
Sure.
when people are walking on them or driving on them and that sort of thing. So sensors are one area, but in theory, that kind of goes along the same lines of rebar reinforcement or other structural reinforcement that they need. The article didn't go a whole lot into the technology that they were using. It
But
was
I
more so
wonder-
just that they did it.
I wonder if you
So-
could. I mean, I've never laid rebar, so
I
I'm
could-
ignorant to that. But I wonder if you could, have a section that gets laid down and then have a section that gets laid down. I'm thinking of like those, you've seen the videos of those pavers where you see like a hopper full of bricks. And
Yeah,
then
yeah.
It lays flat a sheet of paved bricks,
Mhm.
like something like that, where you incorporate the support material. And maybe it's not rebar, but maybe it's something different. Maybe it's a
Yeah.
crosshatch of some steel kind or something like that. But
Yeah, I don't know about the directional strength of rebar, but in theory, you could print a layer,
Pause.
lay down,
Right.
put down a chunk of rebar, and then print on top of it.
Here's a big problem is when you reinforce concrete, there's a few different methods. You're talking about the one where you just lay rebar in and then you pour cement over it. That's fine. But then, I don't build bridges, but I know that they have rebar or really huge bolts that they tighten, and it's all under tremendous pressure when they pour everything, or like when
Yeah, I
they
didn't
put
think
the.
the rebar is just kind of sitting there, is it?
Sometimes,
Yeah,
Absolutely,
I assumed
yeah.
it was like tensioned.
To be fair,
but some is tensioned.
we don't build a lot of bridges out of concrete nowadays. Out of just pure concrete.
We need to get a bridge expert on here because we're really just
We're
speculating
grasping at
here.
straws. Yeah.
None of us are concrete experts or bridge experts by any means. But it's a really interesting topic. I think going off of, again, a lot of what we talked about last month, in terms of concrete 3D printing, some of the more practical applications might start out as pedestrian bridges, benches,
Sidewalk.
construction piping, things a little bit less critical and demanding than homes or car bridges,
Right.
I guess.
And I like bridges better because it's not just a shell.
It's a little more
printed a
structurally
house.
interesting.
Yeah, it's just a shell of a house, but this is actually
It's a
bridge.
rectangle.
What do you call it? So if there's a stream and you're going to build a bridge over it, but there's land or something above it, and you built into it like a cave kind of a thing, right? There's a tunnel. There's a name for it. Can't think of what the name is, but I can see something like that. Like I have a friend right now who is building a winery, and they wanted to build a wine cave. And he basically wanted to buy one of these pre-built concrete structures, stick it into the side of the wall, and say, build the concrete cave around it. And wasn't feasible, long story short. They poured thousands and thousands of pounds of concrete to try to make this.
Let's try to make this wine cave.
And I was like, you should 3D print your wine cave, man. This is how you should do it. We talked about it. And it's not feasible for their project. But I can see those type of structures too, because you can see it. Once you get beyond houses and you get beyond temporary shelters or emergency shelters, quonset huts, whatever you're making with these with these 3D printed houses, once you get beyond that, other structures, bridges and stuff, I think there's a lot more applications for that.
Yeah, I agree. That being said, the next story that we have to talk about, I'm not really sure where the application is practically. And it was probably the most popular 3D printing story over the last 30, 40 days. And so there was a research project out of the University of Hamburg that is doing what they call nonplanar 3D printing.
So you sent me this. I am not an engineer. What are you talking about?
So most 3D printers, and this was pointed out in a video by Teaching Tech, are really only 2.5D printers, which is a reference to how a lot of CNCs operate also. So when a CNC machine cuts a layer, a shape, a profile, an outline, whatever, and then moves down and then cuts a layer and then moves down and cuts a layer, that's considered a 2.5D machine. Usually the down has to be done manually by the operator.
Typically, I guess the easy way to describe it is when you're printing a single layer, you're only moving in 2 axes.
Right.
Because then the z-axis...
Then you stop moving in the XY, move up, and then continue in the XY.
Which is why you have layers.
So you're never moving more than 2 axes at a time.
Okay.
So true 3D printing is when you're moving in all 3 axes at the same time. So instead of going like this, up, you go like this, and move.
So what you're saying...
3 dimensions all at one time.
What you're saying, before the non-planar 3D printing, the only true 3D printing type is the 3D printing pen?
It's a little bit of a stretch, but sure, whatever.
Okay, the first thing that you said that came to my mind with that was the beginning of Westworld. Where, if you've ever seen the opening credits of the show Westworld, they just freeform creating these humanoid structures out of 3D printed material, and it's just so it's constantly in freeform motion and it's appearing as it moves. Or Stratasys had a continuous build model where they basically put an arm
on a robotic arm.
Articulating.
Was it 7 axes in total?
So that's when you have it on most robot arms, those are a lot more than 3 axes. So that's why they can do all sorts of weird movements like I just did. But just 3 could easily be just like X and Y would just be here. X, Y, and Z would be here.
So I guess to make it a little easier to understand.
Ken, please help.
So I think the biggest advantage to this system is surface finish and allowing you to print in more time and material friendly orientations but still get your desired surface finish. So think about if I have a curved surface like a half sphere. Now typically when you print that flat with the spheres like this on the build plate, it's not going to look very good. It's going to look very layered and stair-steppy.
And it's going to be like sliced like this, and
it'll be sliced this way. Yeah. So it's going to look fairly steppy when on your curved surface.
Okay.
Now
stair-stepping is what a lot of people call it.
Yeah, it's just
it looks like
the kind of like
stairs.
this.
Like you can see the layers. They're very visible.
Okay.
If you print it upright, like I guess so, your circle's kind of going like this and being supported. those layers are part of each slice, and it'll look much cleaner. That stair effect is going to be much, much smaller. Now, what in theory you could do with a non-planar 3D printer is you could put your part flat, print the majority of the part traditionally, and your final layer, print it with layers going like this, moving across the top. So you can't make things float. So that's why I think you're a little confused. You can't just move the head up and make it float.
But so most 3D printers go like this: deposit a layer and it drops. Deposit a layer, or FDM, deposit and it drops. So instead of the build plate moving, it's the arm that's moving.
Well, it could still be the build plate.
Z-axis.
You could still have.
You could have.
The mechanics are the same. The instructions to the printer are different. Yes, you're doing great.
Okay.
Perfect.
It's a little bit hard to visualize, and so looking at the pictures,
I got it right.
Like that's it.
Nailed it.
Anyway, it's neat, but outside of just surface finish, and even there, some surfaces are better than others. There's a lot of restraints around where you can have your support material head or your cooling fan or everything that goes around the nozzle that restricts how effective this technique really is.
You're highly limited by the shape of your nozzle and what's around it. So
Story of my life.
Okay. I'm gonna restart.
Zoom in on his face when he says that.
Yeah, please. You're highly restricted by the shape or the amount of curve you can achieve while in one motion by the shape of your nozzle. So I think in the example they did it on an old Ultimaker, which has two fans. Essentially you have your nozzle and there's two fans that provide cooling, and they kind of make a little like V shape pointing towards the nozzle. Well, they couldn't obviously hit the fans when they're moving in 3D. So they can't intersect with the part while you're printing.
Okay.
So you're limited by
right.
I guess the shape and how much space you have in the Z away from the nozzle.
Okay.
So the bigger the nozzle you have, like when you think of the Stratasys machines where because we have the two nozzles, the whole thing's like this big, versus like an at-home printer where you might be able to get one just like barely that big around.
Right.
You can only get a very shallow
curvature
when moving in non-planar 3D printing.
So my assumption is that, nozzle technology is going to be just as proprietary to the rest of the machine as anything else would be, right?
It depends.
Is that an area for exploration for these manufacturers to push the envelope there to see, if
maybe
it's a star-shaped nozzle,
but
if
again,
it's a fan nozzle,
I don't think it matters.
Nozzle.
At this point in time, it only helps surface finish, which you can help in a lot of different ways, like spray paint.
Yeah.
Like unless it has an actual mechanical advantage.
But if you're talking about like this becoming a consumer grade, shortening the amount of time to produce, if you don't have to finish it, then you don't have to finish it.
Yeah.
If you if it's a cost benefit analysis and you're like, all right, I can buy this one, and when I take it off the printer, it's going to be exactly what I want, or minimal fine tuning that may in an economy of scale over the next 5-10 years that could prove to be a difference maker for certain applications.
Right. I just still think in its current state, the times when it's useful is super limited.
Yeah.
Like if you have a part that has a curve that is less than 5 millimeters tall, then you can do it.
Right.
So it's only applicable to such a small amount of shapes, and it's only cosmetic.
Mm-hmm.
So I'm not.
Can it help?
I'm not really convinced. Hasn't been addressed or proven.
I think if you want what you're describing, more production grade or strength orientation factors, you probably end up using a system more like what Stratasys made with a robotic arm to apply non-planar reinforcement essentially. And I've even seen some metal machines, they intentionally print, I believe it's maybe not E-beam, but essentially the 3D welding system where they'll have like a nose cone and they'll print structural ribs on the outside of the cone. So they're printing on a non-planar surface, but that's a robotic arm though.
Okay.
If you need more strength, there are easier ways to do it today.
I think you'll see more push for optimizing 2D toolpaths than worrying about making 3D toolpaths.
Okay.
Yeah.
Because
Can you do that on like anything then? Like if you wanted to 3D print a pair of something on an outfit or something, you know what I mean? Because I know we have another exciting story to talk about.
We do.
Nice transition.
This is my segue into the story about Fashion Week and how one of the big highlights is 3D printing playing a role in the appearance of some of these outfits.
Yeah.
So if I take this dress that I've designed, for example, and now I have this, I'm not going to run it through a 3D printer. I'm going to have an articulating arm, manufacturer design on the front of it, so it's going to have some application for something like that, maybe.
Actually, what you're gonna do is you're absolutely gonna run it through a 3D printer.
Really?
Yes. In today's world,
so no,
that's
I wouldn't
exactly
assume.
what you're gonna do. So in today's fashion world, and this story that we pulled was from New York Fashion Week. They used a Stratasys J750 to print directly onto fabric, and so they would take a sheet of fabric, put it on the printer, print their details on it, pull it off, and then chop it up and sew it, and that sort of thing.
Okay.
So
it
it's
wasn't like using a finished pair of blue jeans.
right.
No. No.
As much as I would have loved that would have been
I'm
really
thinking
cool.
of like an ultra bedazzler 3D printing.
It kind of is, but just for the fabric, right?
Rather expensive bedazzling system.
What was funny is my brother.
Look up the photo.
On Instagram, I saw yesterday. My brother went and spent I don't want to know how much on a pair of Adidas Yeezys.
Okay.
Yeezy 350s. Insanely expensive sneakers. But one of the big concerns that Kanye West had when he first introduced that shoe line was people could 3D print these shoes.
Really?
Yeah, well, if you've seen what they look like, you'd be like, yeah, I could probably 3D print these shoes.
Okay.
But 3D printing your shoes could be a thing. You could just 3D print your own sneakers, like right from your house, right? I think that
There are some companies who have tried doing that.
I know. So Adidas
Still doing
is
it.
one of them. I know they've done some uppers and
New
not
Balance.
soles, but Adidas was
Yeah,
one of them.
parts of shoes
Yeah, sections of them.
is being done today.
Yeah.
The parts that you traditionally think of being 3D printed are the bottom, not the sole, but the rubber.
Yeah.
The bottom part of your shoe. That's what's being printed. The uppers, the stitching, that's not 3D printed. It's 3D stitched.
So I'm envisioning my running sneakers,
Yes.
which have the rubber base.
So that'd be
the
printed,
base, right? But then it has a layer of fabric, but then it has like structural reinforcement of plastic over the top of it.
Like a rubber.
No, it's like hard plastic.
Oh.
In some cases,
Like TPU, like a rigid plastic.
No, not even
Nylon.
More like nylon.
Okay.
Yeah. Very inflexible in some cases, and actually, I returned a pair that I didn't like because they were far too tight because that material didn't have a lot of give when I ran.
Gotcha.
And then when my feet would kind of like splay out when I hit the ground, there wasn't any give because those kind of like held the size of your feet in. But I could see TPU being a material like that can be tugged and pulled over and over again and retain its shape, being a huge application for that. But I could see somebody can we try to print Yeezys?
I don't see why not. That would probably be a great video, is 3D printing some clone Yeezys.
Guarantee you it's trending very, very highly.
What's interesting about this is that usually when 3D printing is applied to fashion, they're talking about FDM.
Yeah.
Like what you're thinking about with the shoes and some other people who use FDM with fabrics. But it was interesting that this was with a J750, a resin polyjet printer. And they talked about using this because they were specifically trying to get something kind of awe-inspiring, like after a pattern after some butterfly. And so they printed teeny tiny spheres as lenses with then color behind it. And so they really were able to leverage some of our multi-material and multi-color capabilities to make
like that
this cool fashion.
Control.
Yeah, exactly.
Yeah.
Now, they also made a claim in this article that I think is a little crazy. They said that within 2 years, consumers will be able to buy 3D printed items from high fashion brands.
Yeah.
I don't see why not.
You're on board with that?
High fashion is it's the opposite of fashion.
Yeah. There's a big difference between like high fashion Manhattan socialite
And, like,
and somebody in
practical.
Milan and like wearing a garbage bag and being like, it's fashion. That's what I call it.
Right.
Like,
we're talking like Met Ball celebrities.
Yeah.
That sort of fashion,
think-
not like going over to Macy's.
Again, you know
Yeah.
why? You know why? But you know why they'll do it? It's because it's a one of a kind.
Mhm.
It's because you can't get it anywhere else, and because you can customize it for you. Personalization starts at the top.
Yeah.
Yeah,
That's a good point.
I think clothing, especially like you, I think what more like you're saying, you're not going to see this at Macy's or common
No,
clothing
not mass.
brands.
It's not for the
not
common-
mass produced. No, common folk, yeah. us down here.
Thank God.
But
because this is so
I-
ugly.
I think that you will start to see 3D printed soles more often. I think that's a more realistic 2-year timeline.
But that's
it's a
mass
part.
production too, though.
I think that can.
I think you'd
I think
see
when
much
you-
more like high end
Now
pumps.
when
and
you
like,
say mass production, we're still talking about expensive shoes. We're not talking about
oh, true.
your $60 sneakers or
True.
stuff like that. We're talking about $350 shoes. They're not mass production at that price point is not like cheap shoes.
Which is what Yeezys go for. So
Yeah.
kind of might as well start 3D printing, dude.
Yeah.
Or someone else will first.
I think
I
there's
guess.
more. There's more.
use this, buy those sneakers, scan the shoe, and reprint it.
There you go.
And then return the
Can I,
sneakers.
the sneakers?
I think you have more application for practicality with embedding sensors in clothing.
Embedding sensors how?
Well,
So
you embed them in a bridge or you embed them in clothing
Okay.
to
so
monitor
like
stuff.
printing
Okay.
conductive, or I don't know if conductive is the right word, materials that can transfer data from a sensor. So the theory would be that you could essentially wear a normal shirt and have sensors integrated into your normal
So-
shirt.
I almost bought a pair of pants, Ken. I think I know where you're going with this. And I almost bought a pair of pants that did this. There was a little like speaker over here, and then when you drummed on your pants, it made drum sounds. Like it was awesome.
That is the coolest.
It had a tiny little speaker, and then you'd be like,
I would have quit.
Slightly
Right,
more.
it's so much fun.
Listening to that all day.
I think my idea might be a little more practical when I get to, but
What's
just,
not practical
Okay,
about
yeah.
that?
Is this just like the grown-up version of those like light-up shoes that you
I was
wore
that-
when
I
you
was that
were
kid in
little?
school.
Yeah.
Okay.
Bopping along, so like to be able to
Okay.
do that and have it actually make like a hi-hat and a tom and a bass tom, like you could do it'd be so much fun.
That'd be so fun.
Yeah.
What I was thinking was more along the lines of like athletics and medical. So with athletics, being able to track data from athletes as their
Understand perspiration, heart rate.
yeah, stuff like that. Like you even see like in football now, we
You
monitor
see blood flow.
blood flow. You can do monitoring like concussions or impact, that kind of stuff.
Yeah.
The medical side, I know I've read multiple articles about how discussing like senior citizens wearing clothing that feels like normal clothes, but maybe sending data like heart rate, blood pressure to an app that can alert people if something goes wrong.
You see that now with
Yeah.
wearables and with the
But making
the
it a
Apple
little
Watch
more,
does and-
like the watch is a pretty good example where it's more practical. But
Yeah.
like a shirt where you're not hooked up to wires, it doesn't feel out of place. It's just kind of naturally integrated into what you already do.
I could definitely see high-end athletes, wearing things like that, like compression socks.
A lot
that
of them-
tell you how much blood flow is actually getting to your feet when you're at a full sprint.
A lot of them already wear sensors while they play.
Yeah.
They're just like on an undershirt with a big like sensor on the front. Like they're hidden, but they're not just a part of their regular shirts.
Right.
Right. Essentially turning like clothing into an Internet of Things.
Oh my
Data
God.
collection,
device.
I don't
Right.
want. I don't want my clothing tracking what I'm doing.
Just wait till Google gets that information
Oh
too.
my God.
Google Pants.
It'll be broken up by then.
But thinking of Internet of Things, it's one of those trends that we keep seeing over and over again. We've been doing a bunch of events talking about Industry 4.0, the Internet of Things, and supply chain disruption lately. And really our last story of the day is kind of falls in line of that supply chain disruption. And this is one example of the Air Force continuing to adopt 3D printing for replacement parts. And so what happens is in a lot of industries, global industries, companies and I guess the military ends up having to stock replacement parts all over the world.
Mm-hmm.
So there's millions and millions of dollars of replacement part inventory just sitting around in case you need it. Because if you're...
Not all of it gets used.
Yeah, and not all of it gets used. You're absolutely right.
Some of it spoils, or not spoils, but, is no longer usable after a certain
It's
amount of
outdated.
time.
I mean, I'm sure they've got stuff that they just legacy because they don't make that plane anymore, don't use that vehicle anymore.
Right.
Right.
And it's a horrible waste.
It's a massive waste. And for global companies and the military, in this case... It can make more sense to, instead of having a warehouse full of parts on every continent so that the parts can be there when and where you need them, just to have a 3D printer to take up a lot of different part numbers on every continent. And then when you need a replacement part, you print the replacement part and you have it right there where you need it when you need it.
So kind of like the 3D printer on the space station.
Yeah.
How expensive is it to... ship up an adjustable wrench to the space station versus here's 80 grams of hard plastic ABS that you can print from there, and now you've made your own adjustable wrench that
make whatever you need, because you may not need a wrench, you may not need a screwdriver, but you make whatever you need when you need it.
Right. And that could open up a lot of doors to a lot of things.
Yeah, I wasn't really thinking about the space station comparison, but I really like that. I mean, it kind of takes this supply chain problem and amplifies it to just such a crazy extent.
So I saw that on PBS.
Did you?
I was watching the show Ready, Jet, Go with my kid.
That sounds like a great time.
Oh, it was cool, actually. And they were eating breakfast, watching the show, and this woman is talking about how JPL does exactly that. They ship up 3D printers because they send one 3D printer and the spools of materials, and that cost benefit is way, way better for them to do that than to send all these parts over.
All the stuff,
yeah. And we can do that on a smaller scale here on Earth, just getting parts as quickly as possible from Guam to Texas.
But as you have more and more
interesting
you have more countries now racing to get to the moon, racing to get to Mars. The future for how we might be able to best set ourselves up to continue to explore those things might be 3D printing.
Yeah.
I think another thing that's kind of expedited this process is recently we saw one of the Stratasys machines, the F900, get certified for aerospace. So now they can produce parts that can go on in-flight planes. In flight. No, but the I think a couple examples they brought up in the past are like I think it was a head mount or headrest mount.
And a toilet seat.
Seat, yeah.
The famous toilet seat that saved like $10 million a year.
It was wasn't it like $50,000 or $40,000 in a year they saved just by printing like 3 of these things?
Yeah.
Wasn't the government spend like $180,000?
That's a different problem. Yeah. But, I mean, you're looking at cost reduction and time reduction.
Yeah.
I think obviously we know the military is not the most efficient thing on the planet, but anytime they can make that big of a price difference, though, they want to do it.
Yeah, absolutely. It pushes the envelope for sure.
Yeah. I think
to the moon.
To the moon. It'll really change how and where things are produced, which is that kind of supply chain disruption. This is just, again, one small example of that greater theme that we've been exploring lately.
And it's not just the United States, it's India, it's China, it's other developing countries that are saying, we're going to go there and we're going to do this too. So if it's not just, one entity putting their force behind it, a global consortium can make a big difference.
Ooh, global consortium.
It's the biggest word I got, and I dropped in. I'm walking away.
Okay. Awesome. That's all the stories we had today.
Yeah, I think we talked about some cool stuff.
Okay. Ken, did you want to say anything about a global consortium?
No, we'll just save it for later. It's okay.
So can I share one little anecdote?
Yes,
because
please.
I think this is so we talked earlier. I spent last week in Disney World, and we went to the Chevrolet test track. One of the rides.
What was test track?
No, it's still.
Oh, it's the same thing, just Chevy. Okay.
So Chevy branded.
Yeah.
So it was really, really cool as you're walking in the queue and you're in line for a long, long time. They are showing these like futuristic models of, Chevy concept cars that are not yet realized or things like that. And, they're about the size of this table and something like that. And in the little placard of information, they will create 3D structures. And I'm like talking to my 8-year-old, I'm like, dude, my company could 3D print something like this, as opposed to, you have to blow mold the door and blow mold the roof and then attach it and put it together and shape it and, maneuver it. Like, this whole thing could have come out of one J750 or something like that. And I just thought it was really neat that I got to find a real world practical application to bring home.
On vacation.
Cool. On vacation. So I just thought I'd share that. I thought it was cool.
That's awesome. Concept models, easy win for 3D printing instead of, like you said, blow molding and painting and doing all that. It's a lot faster process.
And to see it all like put together, I'm like, that would have been a giant pain in the neck to try to like build together. It'd be like a little, make your own die cast kit for God's sakes versus just print it all at once.
You got it. All right, that about wraps it up. Thanks, Kevin, Ken, Ben. My name's Adam. We're from I'm second guessing myself now again.
Okay.
Full circle to that
Monday.
lack of being there on Mondays. If you enjoyed watching this, make sure to hit the like button, subscribe, do all that normal YouTube stuff, and we will see you next month. Thanks for watching.
Have a great day. I'm gonna go with that every time.
Have a great day.
Have a good day. No wait. Have a good day. See you guys.